you think AI is just going to automate the whole thing, that's not going to happen. And that's where it's still a buzzword where AI is going to replace human. That's not going to happen. It's still going to be human interaction involved.
Welcome to Talking Design and Engineering by Makelab. Insights and advice from industry leaders driving innovation and shaping the future of people, processes, and technology in the world of physical products.
Welcome. This is Talking Design and Engineering, and I'm your host, Cinerita. Today I have with us a very special guest. He is an 3D printing operations engineer at Orthotics, USA, with a background in additive manufacturing and production optimization. And he's also worked at Makelab before. Welcome, Shrenik.
Thanks for having me.
So you work at Orthotics now as the productions operations engineer. So when you tell someone about what you do for work, what is something that they tend to get wrong?
So they're usually right and wrong at the same time. When I say, hey, I work at a company where we make 3D printed orthotics, they think of like a sci-fi lab where you go, somebody's going to scan your feet, you go to a printer, press a button, and voila, your job or your orthotics is ready. In reality, the manufacturing is more of a industrial thing rather than a sci-fi lab. Yes, you still go to a clinic, somebody's still going to scan your feet, but there's a lot of steps involved before printing and after printing. And that's the thing people completely get wrong. You still go to a clinic, they scan your feet, and then it's going to go to a printer. There's a lot of post-processing involved. There's a clinician or a designer involved who designs it. And that's the thing they completely get wrong.
Right. Okay. And so the whole process that you explain, where do you come in?
So I mostly work on the printing side of the things. Obviously, we are a bigger company and I'm involved a lot with the design and the post-production, processing, finishing, and all of that. But my job is mostly focused on scaling the AM operation at Orthotics.
Wow. Okay. That sounds really interesting. And before we get into all the technical part, we all have worn shoes and we all know enough about or know something about insoles. So how would you explain the difference between, let's say, something you buy that is very generalized, something you might buy at like a CVS, or compared to something that's customized for your own feet, and what difference that makes?
Very interesting question. You have definitely did your research. So let's say if you go to CVS, buy a orthotics there, there's definitely nothing wrong about it. The way to think about it is it's a very generalized orthotics. There might be few options there. There might be, I don't know, sports, high arch, flat feet, etc. But if you think about your feet, it is not a general shape. Even if you have the same shoe size, your feet is going to be completely different than somebody else. So when you go for a custom orthotics, like what we design at Orthotics, you actually scan the feet. You think about the whole biomechanism. You think about how the forces are traveled through your feet. You think about the pressure point. You think about the gait mechanisms and etc. Then you design around the geometry of your feet. So you're not just designing orthotics for comfort. You're actually thinking about the interaction of your feet to the floor. And by doing that, you not only get comfort, but you also get a huge impact on the performance and the pain and every other problem that you have on your feet. So that's where there is a major difference. Orthotics you buy from a CVS, it's good for cushioning, but it's not designed specifically for your feet. While custom orthotics, by its nature, designed specifically for your feet.
So the category of clients that you work for, what would you say? Is that mostly a general public, someone with specific medical requirements?
So the way orthotics is a grade 3 FDA medical device. So the way it works is you go to a podiatrist. The podiatrist look at your feet and then they prescribe based on your pressure point, based on your geometry, orthotics to you. And that orthotics comes to us. We design it, we print it, we fabricate it, and then it goes back either directly to the patient or to the doctor. They make sure everything looks good, and then it goes to the patient. So we don't directly deal with the clients. We deal with the doctors and much bigger groups as a manufacturing partner for those things.
So what did you know about additive manufacturing before you got into this role? And how has that changed after joining it?
I got into additive manufacturing actually by accident. I had no plan of going into AM. It's a long story, so I won't go too much into that. The way I used to think about additive manufacturing is that it's going to change the world. Everything is going to be manufactured by 3D printing. Some part of me still thinks that's going to happen in future, but we're not there yet. I think AM just as a part of manufacturing process rather than being replaced by another manufacturing.
Right.
So it's a whole system that works because of 3D printing. That changed a lot from my perspective of printing is how I used to think about post-processing.
Right.
I used to think, hey, something got printed on a printer, it comes out of a printer and it's ready. But in reality, that's not the case.
Right.
A lot of time when part comes out of the printer, it needs to post-process, it needs to have support removal, it needs to either have painting, XYZ post-processing done, and that's where you get the final output. Right. So AM is not a plug-and-play system. It's part of a bigger manufacturing system.
Yeah.
And it only works when you have the full system designed around it.
Right. So before starting, they thought it was this like super glamorous, oh, you just go in, get it done.
Yes.
And then once you started, some of that was reduced, you'd say?
Yes.
Okay.
Yes, for sure. I used to be completely like, hey, printing is gonna just, you go and it's just gonna get printed and that's it. It's very industrial process. There is scanning involved, there's designing involved.
Yeah.
Printing is just part of it. When there's post-processing, there's support removal, brushing, sandblasting, etc. So it's just part of the whole ecosystem.
Okay.
So obviously 3D printing is the core of the system, but there's a lot of things involved around it.
Okay. So let's talk a little bit about what you do for work. You manage teams and people as well as the technical sides of things. What is your experience been and what have you sort of learned? Just not about the technical stuff, but also about managing teams.
The biggest thing I learned by managing team is doesn't matter how well or how excellent your system is, unless you have a team who actually incorporate the system, it's not going to work. It's very easy in printing to focus on printer, material, even post-processing, but that's not how your system is going to work. You need to have a team which understand the system, which can act in real time if there's any change in the systems, and only then your system is going to work. Right. Unless AI and robotics makes a huge improvement in next couple of days or a couple of years where robots can run the whole production, your machine and printers are always going to be operated by human. There's going to be technicians, operators, engineers involved with that. So your system is always going to be human dependent. So you have to design your system based on how your team is and work around the team rather than designing a system and try to make your team fit into the system.
What's your take on that, by the way, about robots taking over additive manufacturing?
It can happen, for sure. Let's see.
Okay.
You have to ask Elon Musk. Maybe he's making some kind of automation robot. But I don't, coming back to reality, I don't think that's going to ever happen. There is always going to be human involved.
Right.
Manufacturing is going to be always an industry where it is going to depend on humans. It is never going to get fully automated. The thing I see, a lot of repetitive tasks will be automated. So there is, the automation will be there, but it's always going to be human involvement in the process.
So not completely hands off. Yeah, I believe so too, because like there's just so many parameters and so many moving parts and so many different things. And that's why I feel that is a difficult thing as well. You talked at Rapid.
Yes.
Presented at Rapid.
Yes.
And you talked about running a production line where no two things are same.
Yes.
That sounds a little contradictory. Would you like to talk us through that?
Yeah. So we make custom orthotics. So each and every part we are making is completely different. Obviously, we are making orthotics. You have 2 feet, so there's 2 parts.
Yeah.
There's a huge chunk of our order where even left and right doesn't match up.
Right.
So when you think about scaling that system or scale and make more and more orthotics, you are going to have more and more variability in your system.
Yeah.
So we realized very early on into our journey that there's going to be a lot of machine dependency, a lot of human operator dependency, a lot of dependency and variation based on post-processing. So once we realized these variation, we did not want to solve these problems one by one.
Right.
What we did is we built a whole system around the variability, and that's how we were able to scale up. So we did that scaling by 4 main factors. First thing we did was we standardized our input. Doesn't matter if obviously your part is going to be different from each other. So we want to standardize how that part is being treated, how that part is being printed. Doesn't matter if the part is different, it's always going to print in the same way. It's always going to come into your system in the same way. Second thing we did was we stopped thinking about just an individual part. We started thinking in builds.
Right.
So once we have standard input and we pack the whole build together, then we just had to optimize for each build rather than each part. We have done these 2. The third thing we did was we controlled our machine very well. We have a standard parameter across our whole system. So it doesn't matter if the part gets printed in 1 machine, 2 or 3, it is always going to have same consistent output. Once we have done that, then we also controlled our post-processing. And by doing all of that, we made sure our system will always give us consistent result, irrespective of whatever variability gets into the system.
Right.
And that's how we were able to scale up the whole production.
Wow, that is actually very insightful. Just like designing around the variability instead of for the variability. I feel that like sort of helps to zoom out a bit and sort of control the whole thing instead of zooming in and, just going one by one into each. And I feel that definitely helps with, like you said, production at scale.
Yes.
So how much would your output be?
We currently have about 70,000 pairs printing in a year, and that might be double by next year, depending on how things turn out. But
Yeah.
We're still growing every month, every year. There's going to be more and more orders.
And then I know iOrthotics uses HP multi-jet. Why that technology specifically?
So that decision was taken before I started, and the reasoning behind that was not from printing's point of view, but from where the industry was.
Right.
If you make any orthotics by traditional method, you will have about 5 pounds of waste just to make 1 pair.
Right.
And if you 3D print using multi-jet fusion from HP, you will have about 0.15 pounds of waste. So obviously it was a lot cleaner process. It was fully digital than the traditional method where it's fully manual. It is a highly skill dependent process. So because of these factors, 3D printed and specifically HP and Jeff was chosen.
Wow.
And we have been obviously exploring other technologies, other printer, other machines. So that's more to come.
So can you tell what are the technologies you're looking into or you're hoping you're able to get?
You can name any technology. We have been looking into FTM, SLA, HPMJF, obviously. So it's going to be a mix and match of different technology. And it's coming from business point of view where we want to make as much orthotics as we can by 3D printing rather than traditional manufacturing. So whatever parts cannot suit for the material because of material properties on HPMJF machine, that is going to just transfer into some other technology.
Okay. So, and then just to even understand a bit more about printing for the industry that you are. So you were at Makelab, where you were printing, let's say, commercial parts.
Yes.
And then you moved here, which is medical and parts that interact with the human body. What
Yes.
would you say were like the differences that stood out?
So the biggest difference that stood out was just what a good part means.
Right.
At Makelab, we were doing a lot of prototype, a lot of production runs, a lot of aesthetic parts. So for certain prototype, aesthetics were so important that the mechanical properties doesn't matter too much.
Right.
For certain parts where you were making production parts, aesthetics were not that important, but the mechanical properties were important. But when you think about orthotics, the aesthetics actually becomes part of your quality and part of your production. So when you think about orthotics, aesthetic actually becomes part of its functionality. For orthotics, it needs to look nice, clean, professional. And that is not just because you want it as aesthetic, but it will only work if it is nice and clean and professional part.
Right.
So the way you look at a good part completely changed and aesthetic become part of a functionality for orthotics. And that's the biggest difference I've seen.
Okay. So that's basically just how the QC works.
Yes.
And if it does not look good, it just gets failed.
In a way, yes.
Yeah.
In a way, yes.
Okay. So when also QCing, I believe it must be also some sort of pressure because whatever parts are going out, they are going to be used on a human feet.
Yes.
And if there is any sort of error or error of judgment in that part, it means someone is going to be in pain.
Yes.
So does that show up? How do you go around that?
Surprisingly, it doesn't.
Okay.
So the reasoning behind that is, again, orthotics is being prescribed by a doctor.
Right.
They are prescribing based on the geometry and the scan of your feet. They know what a predictable output would be and they're prescribing around that.
Right.
So the task for us is make sure we get that consistent and reliable output. And if we are doing that, then the pressure is completely off. So we don't have to think about how it's going to interact with the patient, what the results will be. We just have to make sure our system produce a reliable and repetitive product. And if we do that correctly, the whole pressure falls to the clinician and they are the one who are prescribing it. And if they are doing that, then we just have to give them the correct output.
So I think it's just relying on the systems and having them to fall back on so they sort of catch you before you go wrong.
It shifts because as long as we print it to how it should print, we don't have to worry about anything else. Yes.
Yeah, that makes sense because I feel even here at Makelab, we believe that systems really help you.
Yes.
And, as long as those are in place, everything should work fine.
I think of the whole manufacturing at orthotics now as a assembly line, which is just keep moving throughout. Your parts are just moving from one station to other, and your orders are just keep coming in, keep going out continuously. And I think we had the similar kind of thing here.
So talking about these systems more, are there currently any bottlenecks or any sort of frustration points that you are seeing, not just like your job specifically, but in this industry as a whole?
Yes.
What would you say that is?
The biggest challenge we are facing and the whole industry always faces is, obviously there are two industries who are interacting here. One is AM and the other one is orthotics. AM is always focused on better printer, better material, more output. Orthotics are always focused on we need a consistent output. So there's obviously a mismatch. AM needs to understand what works for healthcare and design the systems around that. Material and printers are already here. They have been in the market for a few years now. But unless you have a system designed specifically for healthcare domain, yes, AM is not going to be easily adoptable there. Obviously, there are some top-line healthcare applications where you need a top-of-the-line printer, top-of-the-line materials, but that's not the case for all of the healthcare applications. So AM needs to evolve around healthcare, and only then the whole industry will work.
So do you see that gap being filled?
I see a lot of players trying to fill that. There's still a lot of bottlenecks. Not bottlenecks, but the solutions are not designed for the problem. So it is whether you take that solution and modify in some way to work for your application, or you just go out and look for a new solution.
Right. Just curious, do you know any of these solutions?
We have.
Okay.
Yeah. We have found some solution, have been looking into some other, but there's definitely a lot of, like, I would say, just like a Lego piece. You grab one from here, and then just try to get your output.
Okay. So then, again, as we talk about in the future, where the AM industry can evolve and go to, we are also seeing a lot of AI being incorporated into AM. So what are your thoughts on that?
AM is gonna make a change in this industry as it's making in every other industry.
Yeah.
When you think about AM and orthotics, you might think, hey, it's gonna completely automate the design process. As we discussed, it's not gonna replace the manufacturing or the printing itself.
Yeah.
It might replace the designing completely. That's what people think. But I do not believe that's gonna happen. The best that's gonna happen is it's gonna automate some of the repetitive tasks. It's gonna help a lot on the scan front, where the scan data and the data processing would be much faster and much easier, but you will still need a clinician or a designer to prescribe that device. Obviously, with the whole AI and automation, that whole process is going to be much more streamlined, but ultimately it is still not going to be fully automated.
So do you think with AI just generating designs, why couldn't that work?
Because you still need to understand the geometry, you still need to understand the biomechanics, you still need to understand how your feet are interacting with the floor. You still have to understand the pressure points. And based on that, the clinician has to design the device around that. So with AI, obviously, your start point would be much higher. So you are going to have a ready design, and you are just going to have to make modification for that specific custom part, rather than you have to design the whole thing again and again every time. So that's where there's going to be a lot of automation, and the design is going to be much more streamlined, but it is still going to require an experienced designer to work.
So still a human in loop system, but not completely hands off.
No.
Do you also think that is because it is a medical industry?
Not necessarily, because orthotics and prosthetic works together, and I'm seeing a lot more AI generative design on the prosthetic side. The reason simply being the designs are much more complex. There's a lot more room for generative designs. But if you think about orthotics, it's mostly just designing a one surface around your feet. So there's not a lot of room for generative designs. While for prosthetic, there's a lot more room. So that's where I'm seeing a lot more impact from AI, not on the orthotic side. How are you seeing AI impact in that?
I feel I agree too. I feel the generative side is good with design, but so far I feel we still need a human in loop. I don't know what the future of that looks like, but definitely AI has been helping a lot with automation and just even the systems, and getting the repetitive tasks automated is definitely a plus, so that, we can spend our time doing more meaningful tasks that actually, where we can actually apply our skills. But I think I agree with that point, where I feel, again, it depends. Like you said, for prosthetics, it might work, and not for orthotics, because the more the space for generative and like more space for sort of going custom or, doing that, I feel that can work there, but not orthotics.
You also have background in mechanical engineering. There's a lot of AI and generative design software coming up now. How do you see that evolving, and does that gonna change the whole mechanical design industry in a way?
I feel I like to use the sort of like the phrase we usually use for any sort of analysis or something, where we say garbage in and garbage out. So I feel if whatever input you're giving is not good enough, it's not going to generate a good design. So I feel at the end of the day, there needs to be someone who is, technical enough and understands the requirement enough to give it a good enough input so that it gives a good enough output. Because I know I've been online and I've seen these designs and sometimes they just don't make sense.
How do you give input for a mechanical design? Let's say if you have a jig or a fixture, how would you even define that?
I mean, you could give it constraints, give it sort of like what you want and what you require. You cannot just go and be like, give me a jig.
So you're defining the boundary conditions in a way. Makes
so,
sense,
I need this to fit in this. These are my tolerances. This is what I want. And then maybe it just does the job of generating it, right? But if you just go in and, be like, hey, I want this. And I feel the AI is going to do what it can to the best of its ability, but it might not be what we require. Yeah. You feel like AI in orthotics right now, is it just a buzzword, not really useful at where your pain points are?
It's somewhere in between. It's definitely making a lot more impact on certain things. As we discussed, it's making a lot more sense on scanning data. It's making a lot more sense on removing some of the repetitive tasks. It's making the design more streamlined, but it's still a buzzword in a way that if you think AI is just going to automate the whole thing, that's not going to happen. And that's where it's still a buzzword where AI is going to replace human. That's not going to happen. It's still going to be human interaction involved with it.
So it's more sort of like aiding human rather than replacing them. Right. And so for someone in your position, let's say in 10 years, how do you see that being impacted?
I see it impacted in a positive way. A lot of time, job of operation engineer is just repetitive tasks, keep doing the same thing again and again. With AI, with a lot of automation, I see those tasks being done automatically. So that way, your job evolves. You have to understand the whole system. You have to understand how work is flowing throughout the system. You have to figure out where your bottlenecks are, and then you have to solve those bottlenecks. That's what the operation engineer job will become, rather than just keep running the same routine task again and again.
Yeah, I feel that reminds me of something Duolingo put out actually, and they were talking about AI, and they said about how AI is really here to just, like you said, take away the tedious tasks, so our workforce can work on tasks that are, more meaningful and, can sort of contribute to the growth in a more better way instead of just, being stuck and doing the tedious tasks. So I feel that is something people get wrong most of the times about AI. There's like all of this like buzz around AI is going to replace us and AI is going to take away our jobs. But really, I feel it's just forcing us to, or helping us to be more efficient and actually do what we love. Like as an engineer, I want to work on DFAM. I want to work on the technical stuff rather than sitting and just, let's say, scheduling things on the paper. So if that can be automated, I am free to do things that I actually love. And work around that.
I think engineers always try to do that. Wherever there's a repetitive thing, they always try to automate it. AI is just going to accelerate that more and more. Things are going to be more automated. And that's where you have a lot more bandwidth to think about overall system and make that more efficient. And I think that's where the whole industry is going, and that's where everything is going. It's obviously, it's out in everywhere. AI is going to replace humans. It's going to take your jobs, this and that. I don't think it's going to happen if you are smart and if you're evolving around AI.
So talking about the future of additive manufacturing on a whole, what do you think is something that everyone keeps getting wrong?
Everybody keep getting wrong that We just need better printer, better material, better systems. That's already there. The thing you need is to understand how that's going to actually get implemented, what the pain points are, and design the system around it. It's super easy to buy a printer. You can go to, I don't know, Micro Center or Best Buy and probably buy a FDM machine here. You can go to Amazon. You can get a desktop machine in the $500. You can probably spend $10, $20, $100,000, get an industrial printer.
Right.
It's super easy. But the difficult part is when you try to scale up that operation because the system doesn't exist. So you have to develop the systems. And I know Makelab has done that. We have done it. So AM is still focusing a lot more on just making more printer, better machine, better material. They are not focusing on systems. And that's where the problem is. I see a lot of smaller companies coming around in that area, which are focused on systems, and hopefully industry shifts a little bit on that side. And there are a lot easier system to incorporate these machines.
I think I agree because I feel like you said, anyone can get a printer. It's easy from going to like 1 to 5.
Yes.
But the real challenge comes in when we're scaling and systems. Again, I feel this is what, circling back to the first point you made, where, you know, like your team and your systems built around it really helps when you're doing that. So yeah, I think that's a great point. And I think, yes, like we do concentrate so much on, you know, better machines, better printers, which is also important, I feel.
Yes.
But it won't work unless your systems are in place.
No. I think we are also coming at a saturation point. 90s were the time where printers were like new, they were amazing, like amazing technology. 2010s, 2020s were where there was a huge jump on the machine quality, print quality, cost went down a lot. We are at a saturation point where costs for the printers are not going down as much anymore. There's not as many new materials coming in. So your technology is already there. Now that technology needs to be able to scale up. And a lot of companies are focusing on that. They're not just selling the printers anymore. They're trying to build the whole system around the printer. And that's what customers need right now.
That is a very interesting take. I hadn't thought about it like that. But when you do, you know, understand actually how it works at scale, I feel that's when you realize this. And yeah, I think that makes total sense.
It's not just at scale. Even if you just want to buy one printer and make a final product, not just a single prototype, you don't just need a printer. You need a slicer for that. You need a design software. If you're making it on FDM, you need support removal. If you're SLA, you need cure wash system. If it is a powder printer, you need sand blasters. You need painting, you need post-processing afterwards. So that AM is just part of the whole system and it requires the whole system. And that's where companies are realizing and they're focusing more on the whole system.
Yeah, almost towards the end of it. And to end it, we have a rapid fire round for you. I thought it would be a fun way to end it. So I'm going to ask you questions. Are you ready for it?
Yes.
And I mean, you can answer whatever you feel like. Maybe the first thing that pops in your mind. And you can also take your time. That's fine. Okay. So first would be favorite AM technology and why?
PolyJet, the part that comes out of that machine is just like, you can't make it with anything else. It's just insane.
Okay, I'll take that. One thing that could make your job easier.
Machines which doesn't make any noise. They are super nice and quiet. I would love that, but I don't think that's ever going to happen.
Doesn't the complete silence make you uneasy?
It might.
Okay.
But I would take that.
Okay. Most underrated material in additive manufacturing right now?
Any FDM material.
Okay. Why?
It's super cheap, it's super easy accessible, but the things you can do with that cheap material, it's amazing.
That makes sense. Your favorite CAD software?
SolidWorks.
I expected that.
Always.
One skill every engineer should have that has nothing to do with engineering.
Team management.
I agree. I feel the soft skills are a must. And the last, one thing everyone gets wrong about additive manufacturing.
It's a plug and play thing. It never is.
Okay, and I think that's the end.
Okay.
I hope you had fun.
I did.
Thank you, Shrenik, for spending all that time with us. This is your host, Cinerita Andrandes, and this is Talking Design and Engineering. We'll see you next episode.
Thanks for tuning in. Subscribe to Talking Design and Engineering on Spotify or YouTube, and follow us on Instagram and LinkedIn for the latest in on-demand 3D printing services.